Okay, so concentration is a ratio. And so let me tell you one more thing about ratios. Ready? Now, this right here, who has the biggest circumference? What do you think? This one? Who has the biggest diameter? What do you think? Which one? This one? See, I know you think he's trying to trick me. He's trying to trick me. Well, I just asked you who has the biggest circumference. You're right. Who has the biggest diameter? You're right. But let me ask you this question. What if I took the circumference here, it's little, and I divide it by a little diameter, and I took this one as a bigger circumference and I divide it by a bigger diameter, and I took the big circumference, the biggest one, and divided by the biggest diameter? Did you know that all three of those numbers are going to be identical? The ratio is identical. And, matter of fact, it's that. Every circle. Make a circle as big as the Earth and divide it by the diameter of the Earth. What number are you going to get? Oh, I don't know about that. I do. You're going to get 3.14. Some of you have never even asked yourself the question, what is pi? All you've done is said, when they say pi, I put 3.14 in my calculator. That's all I have to know. Where'd it come from? It's a ratio. Every circle circumference divided by its diameter is 3.14. Every single one. Do you understand that idea of ratio now? Okay. So now let's go back, and here is the bad news about concentration. When I started chemistry, some group of people said, here's how I want to do concentration, and somebody said, well, no, this is better, and then later they have one that is the best. And so it's when you start studying concentrations, these are all concentration units. Now, I'm going to talk about this one a little bit. I'm going to talk about this one a little bit. And this one I'm going to talk about a lot. And this one a tiny, tiny bit. So what I'm asking you to do on this whole page is to say, and I'll talk about this a little bit, is we're going to talk about these a little bit, and they're going to do a lot with this guy right here. Get that? So here's a concentration unit. It's called grams of solute per 100 grams of solvent. Now, you might say, well, why did they do that? Well, here's what they did. Do you guys have both handout sheets? Do you have both? Okay. Take a look at this graph here. This is a classic chemistry graph. As a matter of fact, when I used to teach in the public school, I taught in public school for about 29 years, and I've been teaching here for about 17. That's a lot of years. But anyway, when they had this thing called the end of course test. And so if you took a chemistry class, you would take an end of course test. And that means the state wrote it. The teacher didn't get to write it. They had teachers in the summertime who got together and they made a great big test bank, and they had like 900 questions in a test bank. And in one year, the computer spits out these 50 questions, another year, another 50 questions, you know. Anyway, and that they supposedly, and every single student in the whole state of North Carolina had to take the end of course test in chemistry. Every single year, they always had this graph on it. Now, I think I know why. Because if your teacher spent 0 time on graphs, then you would fail these questions. But if you did spend some time with graphs, you would probably get them right. So I'm gonna help you understand how to do this graph. And so it's called a solubility. Does everybody know the word soluble means? Is salt soluble in water? Yeah, it dissolves in it, doesn't it? Is lead, iodide, soluble in water? That yellow stuff? No. It's insoluble, isn't it? That's why it was a precipitate. All right, so let me show you how to do this, how to read this little graph here. First of all, let's take a look at the axes. Take a look at the X and Y axis, and this is how you learn to read a graph. All right, what's down here? Temperature? Okay, does everybody know what 0 degrees Celsius looks like? You know what that feels like? In that ice water? Okay, so if you have really, really cold water, this is really, really cold water, and here, 100 degrees, isn't that boiling water? Okay, so I think I understand the x-axis. They have water at this temperature, this. Pretty easy, right? Now, watch right here. Watch right here. Look at this one. Grams of solute per 100 grams of water. So here's what they did. Imagine having some beakers. And guess how much water is in every one of those beakers? How much water is going to be in every one of those beakers? Water is going to be the solvent, by the way. How many are you going to put in here? Oh, I lost you on that one. Look right here. It's grams of solute, that's the chemical, in 100 grams of what? All right, so you're going to do an experiment, and you're going to have a beaker, and 100 grams of water is going to be in there. And it's going to be cold water, and then warmer, and then warmer, and warmer, and warmer, and warmer. You get that? So somebody did this experiment, and they did it with different chemicals. Let's try this chemical here. Does everybody know the name of that one? You should. Everybody in this room should know the name of that. So I'm called on J3. What do you think? Let's name that chemical. Yes, excellent. Wow, thank you. Potassium nitrate, isn't that right? Now, so imagine doing the experiment, and they have the cold water, and they start putting potassium nitrate in there, 1 gram and 2 grams. And guess what they have? Look at this graph for potassium nitrate. This whole graph right here is potassium nitrate, and I'm going to go right here. So put your pen right there. Now, what do I know? At 0 degrees Celsius, cold water, how many grams of potassium nitrate will dissolve in 100 grams of water? What's that number right there? It's halfway between 10 and 20. 15. Is everybody okay? Now, they have a fancy word for that, and I'm going to show you some fancy words here. Okay, saturated. Have you ever had it where it rained and the weather person said, man, the ground is already saturated? What does that mean? If it rains again, the rain won't have anywhere to go. It'll have to run down the hills and go, Have you ever heard the word saturated? What's that mean?
Like vibrant in color.
What is it?
Like how vibrant in color is?
No, okay. You could use it in art. You could use it as an art term. But if I'm talking about the ground being saturated, it means it's holding as much water as it's full. It's full. So saturated means completely full. Okay, so I'm going to put that there. So look right here. If you were to put 15 grams of potassium nitrate in 100 grams of water, you could dissolve it and it would disappear. But what if you tried to put 16 grams in there? What would happen if you try to put 16 grams in there? Everybody look at me, okay? How many are going to dissolve of the 16? 15. What's the other gram going to do? It's going to fall to the bottom. You cannot put more than 15 grams in that water. Could I put 14 grams in there? Yeah. If I can put 15, I can put 14, can't I? So so 15 grams would make it saturated, but what if I only put 1 or 2 or any number up to 14 grams? What word do you think what they call a solution that was not full? What would be a good word for that? Yes. All right, so let me, one more time. Here's how you read the chart. Now you're looking at the clock. That means I'm boring. Okay, sorry. Oh, you got to leave, right? I'm not trying to be boring. But. All right, thank you. I'm going to be here at lunch if you need help, because I don't see how you're going to do that on your own. I can help you.
Yeah.
Did you find it?
Yeah, I have one, so Mr. Robert.
Okay. Are you sure you lost it? I really, you wouldn't have turned it in some other stack. I would have found it by now.
We do it in class.
And you would have turned it in with everybody else. It would have been in that stack. So I don't want you to keep talking about I turned it in, because that doesn't get you anywhere. Because I want you to be able to do it, but I also want you to do it the right way.
Are we doing it during class more, or do we have to do it like?
Well, no, you'd have to do it on your own. So,
Because I can't do it after school today.
okay. Well, here's what happened. Okay, I don't mind if you give it to me even at the end of the week, but but I can't spend a whole nother period during class because it just happened to be. What? No, I asked you to do some of those problems, but not. You don't have to turn them in. I just asked you to do a couple of them. So Luke, tomorrow, first thing you do when you come in, somebody weighs it. You tell everybody else in your partnership, say, here's how much it weighs, and then you just take it home and do a little bit, and I'll help you if you need help.
I can write down the lab report or whatever.
Okay, same thing. If you want to, just give it to me this week sometime.
Okay. Thank you.